Hi, welcome again to our next video. So today we will see on a directional control valve in hydraulics. So a directional control valve has some function. So the main function is to start, stop or change the direction of the flow within a circuit. So in our case, hydraulic circuit. So if the valve actuator is detented meaning it has a few levels of switch. So meaning when you press once, so it will go to the first level, then when you press again, it go to the second level. So it can have few levels of switching, and it will remain in the last position to which it was shifted until the detent is released. Meaning the switch will go level by level until you release the switch. Okay, that is what we call as a detented switch. We will see later using our symbols. Okay, the moving part inside the valve divert flow to the internal passages within the valve housing. So meaning inside your valve you will have a few parts that your hydraulic fluid can follow. So that is how the directional control valve control the hydraulic fluid using a directional control valve. Okay, so valve initial position meaning unactuated position can be referred as normally open or normally closed. So we will see later so what's the difference between normally open and normally closed in electrical circuit and also hydraulic valve. Okay, a normally open valve allow main pump flow to pass through the valve. So meaning normally open in direction control valve means that it will have a flow, meaning it's actuated. When we say normally closed in a valve, meaning so the valve is blocking the flow and does not permit any fluid passing through the valve. So that is what we as an introduction to directional control valve. Okay, so you can see this is an example. So this is a end lever. Okay, so we always refer end lever. So this is a end lever where you this it forms like a joystick. So where you can push or pull in order to activate the valve. Okay, and you have a shut off position in between. Okay, so this is just an example of directional control valve used in hydraulics. Okay, so we will see this is a very important part. So normally open and normally close. So what is normally open and normally close? So people always will have a misconception uh, when to use normally open and when to use normally close. So this slide will explain clearly what's the difference between normally open and normally close in electrical and pneumatic. So you need to understand that there's a difference between normally open and normally closed in electrical and normally open and normally closed in pneumatics. Okay, so we see the first part. So we see it in terms of electrical. So electrical, so let's say we take an example of electrical switch. Okay, in electrical when we are saying normally open meaning no connection. Okay, so you need to understand this clearly. So when we are saying a switch is normally open, so meaning normally you don't have a connection, but only when you press, so it will change, it will start to have connection. And in electrical when you are seeing normally closed, meaning it has connection, so normally connected. Okay, so it's on. Okay, that is in terms of electrical. And in terms of pneumatic, so it will be opposite. So pneumatic, let's say we take an example of valve. When we are saying a valve is normally open, meaning is actuated. Okay, actuated when you press, then it will become unactuated. So initially it will be actuated. And when we are saying a valve is normally closed, meaning is not actuated. Okay, so it's the opposite of electrical. So we need to, since we are dealing with electro-pneumatics, so you need to understand whether they are talking about electrical circuit normally open or closed or pneumatic circuit normally open or closed. So you need to pay some attention. So similarly for hydraulic also. Okay, so we'll see some examples of direction control valves that we can use in hydraulics. So I have listed here around 6. So it's not only these 6, but you have a more directional control valve. So it's just a discussion for a discussion point. Okay, we'll see the first type. So 2/2 way directional control valve. So the symbol is almost similar like in pneumatic, but this is for hydraulic. So although the symbol looks same, but the connection, so it won't have a connection from compressed air and exhaust. So instead in hydraulics you will have connections from your pump, and the exhaust will be replaced with tank. Okay, we will see later in the circuit. Okay, so in this figure, so you see illustrate is normally closed. So normally closed 2/2 direction control valve. So when you have normally closed, so it's an unactuated position. Okay, so you can see, so you have pressure here, but it's blocked. Okay, it's blocked, so meaning no connection. So pressure is not connected to port A. So in its initial position, so P is the pressure is blocked, so no fluid flow. So then you can see this is a actuator position, meaning you are pressing this button. So you can see spool 2 was shifted, allowing fluid to flow from port P. So you can see port P and port A is connected. So P open to A, so meaning there is a full fluid flow. Okay, so that is a actuated position in 2/2 direction control valve. So it's more simpler direction control valve. Okay, now we see 3/2 directional control valve. So this is something that commonly we will use. So it has 3 ports. So the difference between 2/2 and 3/2 and 5/2, 4/2 will be the additional functions that you can utilize. Okay, let's say your application requires more ports, then you can use the direction control valve with more ports. Okay, so that's the only difference. Okay, so you can see, read the first. So 3/2 way direction control valve is similar in design to 2/2 way direction control valve. So the only difference will be it provide an additional function. So meaning you have an additional port. So 3/2 way valve allows fluid to return to tank. Okay, so you can see the word T here. So meaning is returning back. So you cannot release the hydraulic fluid to air or the surrounding. So it will be dangerous. So in hydraulics, you need to, all the excessive oil must be returned back to tank. Okay, so you need to understand that. Okay, so port P, the source of pressure, is blocked. So in this initial position, so it is blocked, but when you are pressing the push button, so you can see there's a connection between port P and port A. Okay, that is on 3/2 direction control valve. So if you see 4/2 direction control valve, okay, is a bit different from 3/2 directional control valve and 2/2 way directional control valve. So the only difference is it lack of ability to block a port. So meaning it just switch ports. Okay, so you cannot block the uh, pressure port. So you only can shift to the various port. So port B or port A. So that's the only difference between 4/2 way valve. So you can see the second point, fluid can flow to either working port A. So you can choose whether the pressure will go to port B or port A. Okay, depending on the spool position. This is a spool. Okay, so the initial position is based on the reset spring. So since you have a spring inside, so you can see you have a spring inside. The initial position is depend on the position of the spring. Okay, so you can see initially the initial position or the unactuated position, pressure is flowing to port B and port A is connected to tank. A is connected to tank. So when push button 5 is pressed, the reset spring is compressed and the spool will start to shift, and you can have a connection between P and A. So it will be connected and B will be connected to tank. Okay, so you need to understand that. Okay, in hydraulics you need to connect all the unactuated port to the tank. Okay, so we have another type of direction control valve we call as 4/3 direction control valve closed center. So closed center meaning since you have three here, you have three boxes. Okay, left, middle and also right. Okay, so the unactuated or initial condition will be in the middle. So closed center meaning all the ports, you have four ports here, port A, B, pressure and also tank. So all will not have connection in the unactuated position. Okay, in the center position, P, T, A, B are blocked. Whether the cylinder is extending or retracting, when the valve is switched to the center position, the fluid on the piston side and rod will be trapped. So meaning in the center, no hydraulic fluid flow will happen. Okay, so the cylinder will stop accurately in the middle stroke. Okay, so the disadvantage of a 3/2 direction control valve closed center. So the pressure relief valve must divert full system flow back to tank. So meaning when it's in the center position, so all the ports, port A, B, pressure and the oil from all these ports must be channeled back to tank. So what will happen? So this is undesirable. So meaning you don't prefer this because since hydraulic is using oil, so it can cause friction, and the the friction will make the oil become ET, and you will have energy loss. So one side the damage will be for the fluid, hydraulic fluid, so it will become less viscous, so it won't be too effective, and the other side you will have energy loss. Okay, energy loss, and you need to remove you need to have a few other steps to remove the produced heat, so you need to understand. Okay, so these are some way of adjusting and adjusting the system. Okay, so you can see it's in the middle. So when you have hand lever, so then your cylinder will extend. Okay, and when it's connected to the right hand side, so your cylinder will retract. Okay, so we have another type. So 4/2 direction control valve tandem cylinder. Okay, so recirculation, so you can see, so tandem, it look like a face with eyes and also mouth. Okay, so that is what we call as tandem. So pressure is initially connected to tank, and when you shift, then it will connect to the respective port. Okay, so you can have a recirculation in the center position. So it's a more improved solution for the previous case. Okay, previous case it produced energy loss, and also the oil become hot, so you can reduce it by having a direction control valve in a tandem center. Okay, so the valve will control the position of the cylinder exactly as the closed center valve does by blocking the A and B port. So meaning, so initially it won't have any connection to A and B. Okay, similar like the previous valve, but since P returns to the tank, so initially, so P returns to the tank, the fluid is not forced through a pressure relief valve. So meaning you no need to control the pressure, okay, because it's initially it will be circulating until you press. Okay, so at the advantage of this type of valve, so it greatly reduces energy loss in the system, and your oil will not become ET. okay, and it will not damage the quality of the valve. Okay, so you need to understand that. Okay, so and we have another type. So for 3 direction control valve open center. So when the valve in the middle, okay, you can see all connected. So the system will return to tank. The system will return to tank, and you can see fluid under pressure also will be released back to tank. So all the fluid will be connected and returned back to tank. Okay, if an external force is applied on the piston rod, the fluid remaining in either side of the piston will also return to tank. Okay, so meaning this is another setup, okay, where all the excessive oil will return to tank. Okay, doesn't matter where when it is in the in any type of position. Okay, so this is a detented input, so it has few levels. So you press once, it go to the level 1, you press again, you go to level 2, press again, you go to level 3, and you press again, it will be released. So that is an advantage of detented input. Okay, so advantage of this valve allows cylinder to be positioned for mission adjustment. So meaning when you want to make adjustment to the machine, so you just place it in the unactuated position, so all the oil will be returned back to tank, and you can do the adjustments to the machine easily. So this can be preferred in the industry. So assuming that the system pressure remain very low, since all are returned back to tank, so the system pressure will be very low. Any pressure prevent from the valve and the cylinder will be released back to tank. So the open center type of direction control valve, it has advantage when so all the cylinder and the excessive oil will be returned to tank. Okay, so that is on the this type of direction control valve. Okay, concluding. So reviewing on the valve symbol, so you can see few symbols here. So this is a 2/2 direction control valve. Okay, so 2/2, 2 ports. Okay, lever actuator, so you have a lever here to push and pull. Okay, it's a spring offset, okay, or spring loaded. Okay, detented, so you have a detented input, and it's a normally closed, so meaning no connection. Okay, then you have a 3/2 direction control valve. Okay, you have 3 ports. Okay, the others are the same. Okay, so lever actuated, spring offset, detented, normally closed. Okay, so 4/2 direction control valve, we have 4 ports. Okay, so lever actuated, spring offset, so you don't have other inputs. Okay, so you must know how to name all these valves. Okay, so you have a 4/3, so 4 ports and 3 boxes. Okay, 3 states. Okay, so you have a closed center, so in between is closed, and lever actuated and detented. Okay, so you can draw your lever actuated either way. Okay, so this is a push type, this is a pull type. Okay, so for this, so you have a tandem center in the middle, so the others are the same, so lever actuated and detented. Okay, so then you have the last one. Okay, this is the open center. Okay, so you have a 4/3 direction control valve and lever actuated and detented. Okay, so I think with that we will conclude our today's video. So it's a short video on the direction control valve in hydraulic. So I hope you will understand. So if you don't understand, please listen back, and we will see for the discussion. Thank you.